Hi, I'm Zach, and today we're going to build DJ Doodle, a collaborative drawing game. We'll build this using Daphne, NextJS, and Nginx. If you'd like to follow along, all of the code is on GitHub. Before we dive in, let's do a quick demo so we know what we're going to build. The idea of the game is that both players are drawing the same scene but different parts of that scene, while they receive prompts generated from OpenAI. Whenever this countdown timer reaches 0, they'll receive the next prompt from OpenAI and continue drawing the rest of the scene. But really, all of this is just an excuse to play around with async web processing in Django and Daphne. I can do a quick demo here to show that if I draw a line as the player on the right, the player on the left immediately sees that line. And likewise, of course, I can draw a line on the left and the player on the right also sees that line. So let's go ahead and dive into how all of this works. First, let's take a look at the requirements.txt file that lists the dependencies for the DJ Doodle project. We have Django 4 as a dependency, which we would expect since we're using the Django framework. The WebSockets package implements the low-level protocol needed to make sense of WebSockets so we can read and write to them in Python. Next up, we have the Daphne asynchronous web server package. We need Daphne because our WebSocket connections are long-lived. That is, they're going to stay open the entire time we're playing the game. A traditional synchronous web server is not well suited to WebSockets because they have a limited number of connections they can serve, and each WebSocket ties up one of those slots, if you will, for the entire life of the WebSocket. An async web server can handle other connections anytime the WebSocket is idle. The channels package adds capabilities on top of WebSockets, like the ability to broadcast messages to subscribers, which we need for our game. Channels Redis is useful because, while we don't need this right now, it allows all the same channels functionality to work if we have multiple web servers. And lastly, we have the OpenAI package, which we'll use to generate the drawing prompts for the game. Let's take a look at how Docker Compose and Nginx tie the whole project together. We're hosting 4 distinct Docker containers using Compose. The Daphne container listens on port 8000 and looks for an asgi.py file to start, which we'll take a look at in a moment. We need 2 environment variables for Django here. We'll use the Redis host variable to tell the channels package where to find the Redis server. The value of that variable is simply the string Redis because Docker Compose adds a DNS entry inside the container that points to the service that we've conveniently named Redis on line 22. The volume statement on line 11 maps our host project directory directly into the container so we don't have to rebuild the Docker image whenever our code changes. That depends on key just tells Compose that, hey, we need that Redis container running before you try to start the Daphne container. Next up is the NextJS container, which serves as our front end. This one's pretty simple. You might notice that it's missing a command section. That's just because the command is specified inside the Docker file instead. There's nothing too special about the Redis container aside from the fact that we're mapping the internal port of 6379 to the same external port, since that's the standard network port for Redis. And last but not least, we have the Nginx container. You might notice we're mapping 8000 to 80 here. We're doing that because 80 is what we call a privileged port. We could map 80 to 80 here, but you might run into permission errors. The volume section is a little special here too. We're mapping a custom Nginx config file, seen here on the right, into the container so that Nginx knows how to handle routing for our Daphne and Next.js apps. Nginx sits in front of Daphne and Next.js so that we can work with a single address and port. The location blocks on the right determine which of the 2 servers should handle a request. Daphne will handle anything prefixed with the string API, with all other requests going to Next.js. As I mentioned a moment ago, Daphne looks for an asgi.py file when it starts. This file tells Daphne what kind of connections it needs to handle and where it can find the routes that make up the application. So we can see here on the left we're telling Daphne to expect WebSocket connections and that our routes will be defined in this WS URL patterns module, which we're looking at here on the right. Because this is a pretty simple game, we've got just the one route handled by what I've named the draw consumer. We'll take a look at that part next. The draw consumer contains all of our server-side game logic. At the top, we create an OpenAI client and a system prompt to explain the game to OpenAI. Every WebSocket connection gets its own instance of the draw consumer class. Some methods of the class are part of the standard WebSocket lifecycle, such as the connect, disconnect, and receive functions. You can see on line 110 that we tell the channels package to add this WebSocket to the draw group, so that this new WebSocket will receive any broadcast messages that we send later. Because we're keeping this project relatively simple, we fetch the game prompts from OpenAI once the first connection has been made. That happens in the fetch prompts method. We use fetch lock, which is an async IO lock object, to make sure only the first connection triggers the OpenAPI call. If the second player connects while we're still waiting for the prompts, they'll trigger fetch prompts as well, but that instance of draw consumer will end up blocking on fetch lock instead and never executes the OpenAI API call. So going back to the connect method, we can see that once fetch prompts is done, we send a batch of prompts back to the user, and as a last step, we create an async IO task that runs separately to keep track of the game's countdown timer. The countdown timer task is pretty simple and just broadcasts updates of the time remaining to every player. Lastly, the receive method just broadcasts every message it gets back to other players. This is how what one player draws is reflected on every other player's screen. Jumping over to the NextJS side of things, let's take a look at the main component that drives all the action for the game's UI. Since we just got done talking about WebSockets on the server side, let's take a look at how they're handled on the client side. The first thing our component does is establish a connection to Daphne through Nginx. If you look at the onMessage callback, you can see how we differentiate messages with a type key. Messages can contain the prompts, an update to the countdown, or as is the case for 99% of the messages, drawing data from other players. If we scroll down to the JSX, we can see that the drawing data is passed down to the canvas component, and data comes up from the canvas via the onMouse event handler. We pretty much send that data, which consists of mouse coordinates and the currently selected color, straight to the Daphne server. Other components on the page include the color picker, a countdown timer, and a pop-up for showing the next game prompt. I hope this project has been a fun way to dive into WebSockets if you haven't had a chance to use them before with Django. The full code for this project is available on GitHub, and I'll link to it in the description. For my next video, I'll show how you can deploy projects like this quickly and easily to the Circumio.io Django hosting platform. Have a great week, and I'll see you next time.